The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont of HawaiiTracker.com, bringing you guys another Hawaiian Volcano Tracker update. Today is Thursday, February 9th, 2023. We've had some minor changes in Kilauea only, Dane, nothing really major, but there's a lot of minor stuff happening, lots of little things to talk about. There were 6 different places that lava erupted on the crater floor over this last week. We could talk about all the different spots that's happening. And then most recently today, we have a new deflation inflation event and lava is dropping again. And we're seeing the islets all becoming exposed, as you see in that video looping here between us. How you doing today, man?
All right, doing pretty good. Yeah, I've been hearing about people asking about what's going on today with that deflation cycle that we've been going into. And the dropping lava levels. Been a common question, been coming through. So we'll talk about that and also go through some of the photos that we've been getting submitted to Hawaii Tracker. If you're not a part of that, that's a Facebook group that we kind of operate out of. A bunch of contributors there, professional photographers, some really talented people. So we're going to pull some of their imagery and share it with everybody. And if you have any questions, make sure to throw those in chat and we'll try and get it, some of them answered at the end.
Sounds great, mahalo, Dane. So that being said, here is this week's sorry, start that again here. Here's this week's Hawaiian volcano summary. On Kilauea, we have this image, just a loop of the last 24 hours from the V1 camera that's showing the lava levels over the last 24 hours dropping down and those islets being exposed there within that eastern lava lake. This is one of 4 spots that lava is currently erupting on the crater floor. There's Eastern Lake, there's a central pit, there is the western pit that was from the previous eruption, and it's got a southern pit as well. Those are the 4 the USGS is naming. And we've also had a couple of spots where lava's oozed up on the crater floor over the last week, both in the northern and southern sections here. So let me see if I can show you a little bit of that here real quick. So this is a little highlight of infrared from Kilauea, showing that eastern lake on the top, the central pit in the middle, and that western lake's at the bottom. You see a little bit of ooze-up flows coming in on the sides, left and right side of the screen there. Those are the ones that happened over the last week. And then big overflows from that central pit. You can see as large as that eastern lake there. Right? That's central area right in here, making a flow that's just as big as this more persistent lake over here. So that's been all the variations of eruption on Kilauea surface in the past week, and we'll go into more detail on that in our full update. On Mauna Loa, the story is the same. Mauna Loa is not erupting. There is no change in activity or in a hazard or prognosis there. There is one sentence I wanted to pull out from the USGS update this week, and that is here. The formation rates show inflation somewhat above background levels, but this is not uncommon following eruptions. So that's the long and short of Mauna Loa. She's following the typical post-eruption pattern, and there's nothing new to report there. So we'll check back in real quick here on our Kilauea live stream. And here's a current live view showing those islets exposed above the lake surface there, and you see still spattering ongoing within the pit right in here, and some overturning of the crust, which is stagnated here within this crust, within this lake surface, but it is still overturning and producing red lava in those areas. We're also starting to see some collapses. Some of the back walls are starting to collapse. Now the lava level is a little low, and even some of the little islets are causing little collapses that can be seen as rubble on this hardened crater floor. So that's the Hawaiian volcano summary for this week. And now we'll get into the more detailed part of the update. And for that, we'll go straight into our Kilauea observations this week. So obviously, what we just showed you is the most recent current thing, but I wanted to start backing up and go to our most recently released map. So this was released last week, and it was from a flight that was performed on February 2nd there. So we have here mapped out on the red color, then in a pink color, the recent extent of lava on that crater floor. And then yellow is the pieces that have not been covered this year in 2023. So that is the extent of it. It hasn't changed a whole lot, but it gives you an idea of the dimensions. And if I zoom into it right here, you can maybe get a little bit better view. That is the eastern lake right there, and a little yellow spot right there in the southern part. That's that persistent fountain right in here, right in there. Hard to draw in red on red, but there it is. Here's our central pit that's hosting that small lava pond and overflowing quite a bit recently, right? You can see this yellow is the high ground over to its west, so most of these flows are staying over on the eastern side of the crater as well. And then there's a lava tube that connects, we believe, this pit over to this direction to that western lake. And this is because when this lake started to refill within the first few hours of the eruption, we saw the lava pour in from this side and then circulate the opposite way that it was flowing from 2021 and 2022 within this western pit, and disappearing back underneath the crust here at this western end of it over here. And then a fourth one they're showing is this small, what I've often called that southeast pit when we just had this western area here. So now they're calling it just the south pit, or the south pond. And this one's connected by lava tube as well. That's right in between these two. I'll draw it and right there, something like that. Connects these two. And that's been a little less reliable. It seems like within the last week, the flow within the southern pond has stagnated and actually gone dark for times and then returned after a while. Meanwhile, the western pond itself has been the most reliable, the most consistent. It's showing some variations in lava level that correspond to what you're seeing on the east side as well, but much, much steadier, no overflows, no stagnation within the pit, and business as usual in there. And the two overflows, ooze-up flows that came around the crater, the margin of the crater, that one on the south was somewhere right in here, and one in the north was quite a bit larger. They're saying it might have been as large as that, or larger than, lava lake. So I would guess something like that, right? Some size more or less like that. So it's filling in this area that's close to the downdrop block, but it has not quite built up enough where it seems like it's imminently going to spill over there. So we're all waiting on that. And to really have a better idea of when that might happen, what we've done in the past is calculate the eruption rates to the volume remaining within the area here from DA measurements and all that. But that's been more difficult. And I'll scroll down past this cross-section here just to read the caption first here. Recent HVO helicopter overflights have been unable to produce accurate structure from motion models of the Halemaʻumaʻu crater floor due to the thick volcanic gasps, and no updated statistics can be provided for the average crater floor elevation or erupted lava volume. Since thermal images can see through the plume, updated eruptive features were digitized from the thermal images captured during the overflight on February 2nd, and the extent of that red lava lake is 26 acres, 11 hectares. The full extent, 294 acres, and they also have now included topographic profiles. So that's what I'll zoom into here next. So that's why we don't have volume measurements first. We hear our statistics at the top just showing active extent and full extent, but no volumes due to what he just explained. So we have to wait on the calculations for when it might spill over until we have better information there. But it seems like it's getting close. And one interesting thing is if these ooze-ups keep occurring along this margin that's next to the downdrop block, then it seems like a little easier for it to occur because it can ooze up from the area right next to where it can flow out, as opposed to having to traverse some of these other many acres of these 300 that are down in here. So that's the volume aspect of it. However, the cross-section is really interesting too. So it's this pinkish magenta color right in there. That's the 2023 eruption. So you can see there's a little bit of a gap. It's touching the red line below it, which is 2021-22 in several areas, right? The high ground that was not covered by lava yet this year over here. So there's that moat that occurred to the west of it over here, and most of the rest of it occurring over here in the eastern side. His cut doesn't quite go through that in the highest piece of it, but it gives you an idea of how far we've come. Not a whole lot in elevation, really, from the pink to the pink from the red here this year. And in comparison, back to 2020-21, December 2020 to May 2021, that got us up to this elevation through here. And down here is how high the water got within that pit before the eruption came in and blew it all away within its first 90 minutes in 2020. So it gives you some idea of how far we are, and this is that overflow zone we're talking about right here, where it might spill over onto the downdrop block in that area. But you can see there's still some ground that's going to make up there, right? And of course, this is not cut through exactly on that lowest piece, which I estimate to be somewhere in here. Right? So we're probably looking more at a cut that's going across something like this. Right? So we might want one that's more. Yeah, it's just hard to generalize from that one section exactly how far it is in this area over here. So probably not quite as much as it's showing on this image, but there's still a little bit left in there. So that's the map that we have for this week, and we can see the thermals that were produced alongside of those. So here they are. There is that larger caldera. There is that downdrop block from 2018 collapse. Still a lot of area to recover. And here we are, there's that edge of that block within that innermost pit where the lava is filling, hardened and not releasing heat as much as the open lava, which is the yellow and red here. And so there's that zoomed out view, and then a more zoomed in view showing the area of that persistent fountain there, and then you see where you have breaks in the crust and several of the islets visible in this image as well right in there. Interesting to note that, make it bigger in case that's easier to see for anyone. So that's the thermal of the lava lake this week. We have a few images as well to help catch us up on the visuals, and we like to show lots of time lapses, and we'll do that as well this week, but just thought I'd throw in a little bit of different views to help orient as we go through the time lapses here. So this is from February 2nd overflight, that same event that produced the maps. And here we are, Mauna Loa in the background. There is a lava complex within Kilauea. Everything is still within this innermost pit. Right, this is the edge of the downdrop block. That's to the pre-2018 floor is over here. And then all this is a collapse in 2018, and right in here is that zone of overflow that we're considering right in there. So that was looking more from the south. Now we're turning and looking from the east to the west more so. And so that overflow zone would be more in here. There is that eastern pond, western pond, and central pond, which in this image is actually seen to be breaking out and producing lava flow at that time that they flew over on the 2nd. There's also a second ooze-up lingering activity happening down in here. And so this is something that we noted that the ooze-up flows can be really, really fast when they come up and cover a large area. And usually that large area will harden, and then it might stay persistent at lower levels in a smaller area for a longer time. And that has been the case along this northern margin, it appears, for most of the last week. So that's the view from the east, and I'll keep going. I think we get a full 360 here. Now we're looking more from the west. No, it's more from the north. Yeah, more from the north there. Yeah, so there's that central overflow, maybe a little better view, right? There's west, central, I'm sorry, this is the east, central, and then here's the west. And the south, not quite visible, as would be a little pit right back in here. So I think there's one more going around. Yeah, here we are. Here's the west view. Or no, we're back to the east view. I got confused here. So anyways, from the east view, there they are, 1, 2, 3 once again. And all the fume and volcanic gas is what was reported that was blocking the structure for motion, right? So the structure for motion, in case you guys don't remember, is when they fly around and take images from every angle, and then they basically make a 3D model of how that all fits together. And the computer likes to have the points where it can see everything all around, and so the fume obscuring the landscape is apparently one of the limitations of this approach that they're using. When you have a whole lot of gas, they can't image it well enough to actually calculate those volumes. So that's interesting to note. And it's been a rainy week here, and it's a rainy day on Kilauea still today. So as we check into our views later on, we'll probably see more of this fume coming up and around. But let's turn now to our webcam summaries, and I'll start off with the KW camera. This is that view from the west. Here's finally my west view. And I'll put it back, and I think we're starting it on the 29th. So this is not quite 2 weeks, but over a week for sure. And this is running day and night. So I wanted to show you the sequence in the context of what happened last week as well. So here's our low-level persistent ooze-up activity in the north part of the field of view. There was our draining of the lava lake last week, and then a return of it, and that full extent once again. Central pit is visible, flashing here in the middle. There's an ooze-up flow coming up on the left, and there was a similar one that happens on the right, but it is not as visible in this image. You see a little bit of glow coming through there as well. And we still see glow from this west vent pond. There's another spot over here all the way to the west by one of these ooze-up vents that recently formed over there. You might see the flashing here in the middle. I can maybe rewind this a little bit. Let's see if it allows me to put the controls on the screen here, but let's start it there. And so then we have our big overflow out of that central vent, and then continuing, not quite as big, but still big overflows as we have our dropping of the lava level there in the background. So this is the wide angle view, which is the only one that catches all these marginal activity. So having documented that, we'll turn to the thermal image that we started with today, but I'll play a little longer back from about 2 weeks ago coming forward as well. So I'm going to put it back at the beginning here. And here it is. So back to 2 weeks ago, we have some small overflows from the central pit. Then we have a bigger overflow that occurs. And then we have the draining of the lava, then it returns, another overflow of the central pit. And then we have fairly steady activity for most of the last week. So small scale overflows from this eastern lake there. We have a few smaller overflows from the central pit. You can see there is a ooze-up flow coming in on the side of the screen there. And we might catch another one on the right. There it is. You see the west area, western pit is steady the entire time. Whereas here we see our central pit pulsing once again, and now we have another big overflow comes out. Another big one once again occurs last night, and then kind of the tailing edges of that, and camera turns pink here because of the extra rain clouds and the steam in the air there. But what you're seeing is, once again, another big burst of lava coming up out of the central pit that precedes this deflation event and the draining of the lava up here in the north pit. So that's really fascinating to me. And one thing that, maybe I'll play this again here while I try to tie this together for those of you guys who haven't followed us for a while or could use a refresher. We talked about the deflation inflation events, and I'll show the deflation inflation of the ground in a bit here when we talk about monitoring. But it's always been a question of what's actually causing these DI events, as they're often called. And one of the leading notions is, excuse me. Oh, sorry about that.
Take your time. Yeah, a lot of action up there. A lot of little things going on. More nuanced now than it was a couple months back when we were just staring at the same pond that only fluctuated a couple feet in height, basically. When we were
for sure,
right before it shut off. Now we have multiple lakes popping up, multiple sources, all kinds of stuff.
Yeah, and just to emphasize, it's all on the surface underneath the crust. It's basically that surface expression, which is really interesting, but it's not really changing any hazard for anyone. So it's not becoming any more dangerous for anyone. Any of these changes are actually going to change how anyone should prepare or view this volcano today. But yeah, it's been really interesting. And so yeah, back to the deflation inflation. It's the idea is kind of like that gas pistoning, right? Where you have two ways the lava can have the gas involved with it, right? One is it can be really well mixed, and the bubbles can be throughout the lava everywhere. And when it happens, the lava has this kind of a steadier kind of effusion, right? If somehow you can have the lava stored somehow, or have some pathway where the gas can start to separate from the lava and collect into bigger bubbles and bigger volumes, then you start having a separation. The lava where the gas came from, it then becomes gas poor, and that makes it denser. The lava mixing into the gas mixing into the lava is what makes it the light. It's the gas that makes it light and frothy that makes it come up to the surface, right? So if you have it go flat, so to speak, then that lava that's denser is going to want to drain back down. But it can't do that if lava is continually coming up and up and up and up all the way out the pipe, right? So the idea is if you had a separation of the gas and the lava, and the gas comes up as one big slug and actually bursts its way out of there, now suddenly you've made extra space within that conduit system that you can drain down the dense stuff. And while it's draining down, the analogy I've used before is it's going through some really skinny hallway, right? The conduit it's going through is small enough that it can't fit the stuff going down and the stuff coming up at the same time. Maybe you've gathered too much stuff to go down, and that's what is actually triggering it. But in any case, you have this deflation event as that denser stuff drains back underground, and then the reinflation when it clears all the way out, and then that fresh hot stuff can come and replace it back again. So I'm not sure I explained that the best. I'm my choking there, but yeah, the idea is that if we're seeing a big burst of gas actually occurring before the deflation inflation events, and that's twice now. We've seen it last night, and we saw it last week as well, where we saw the burst of lava come up. I'll play it again here. Maybe I'll zoom it in. Right, and so there's lots of small bursts, but we're looking for like the biggest, largest one, right? So the one we had this week was larger than last week, but within the context of last week, that largest one is what preceded that dropping event there. And so we have a few small ones. There's another small one right once again there, but when it comes up to the end, you'll see it's going to burst out all the way out, and then the lava level is going to drop. So it's one of the first times I actually can think of having what could potentially be a forecaster of a deflation inflation event, right? If we see a giant outburst from the central pit under these current conditions that exist right now today, which may not last much longer, there's that big outburst right there, secondary pulse. And then now we see the lava level start dropping after that occurs. So interesting how that happened twice. I wasn't able to line up the tilt plots today, but that is really, really fascinating to actually have some insight into that. So that really lends some support to the idea that it's separation of the gas. You're seeing the gas come up first, and then you're seeing the deflation occur after that. So that all seems to tie together and make sense, and it's a interesting data point to incorporate there. So pretty cool. I'll come back to more of the thermal stuff in a bit, but while I continue here looking at that recent event, let's turn to the S1 camera, looking from the south. So there's our persistent lake in the south. We see our islets drifting around there in the middle of the day, and there's a big outburst that occurs here on the left. That was from 2 weeks ago. So here's our last week draining of the lava, separated into 2 different areas, and then reflooded and resumed its previous extent. Mostly, you can see there's some benches that were isolated then and here and over here on this northwest side as well. And now you see, just in the last day here, the lava level is dropping, more islets emerging. You see higher relief from these edges. Let's see if I can freeze it. One of these better, less rainy contrast. There's one. There's a good one right there. Right, so there you still see these benches here in the northwest and in the southeast. It's fascinating to note that the fountain is still there, but look at how many islets have emerged out of the lake, right? So I estimated over a dozen. Quick count, I'd say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This bundle back in here, there's a 12 back in, maybe 12 for here for sure, but this bundle counted as 11 may actually be 3 of the older ones that have to have fused together here. So depending how you count them, you got at least a dozen in there. And so fascinating how that's occurred. And it seemed like some of these benches occurred the last time. Some of these cracks in the outer wall here seem to have occurred over and over whenever the lava level drops, and we saw that forming last week. And we'll see more of these occurring here this week too. But focusing on this eastern section over here, it seems like when the lava level drops, we do have this bench exposed, and it seems to connect to form a ridge with these islets that have clumped together over here to not exactly the same as before, but it almost seems to isolate our lava lake into 2 different areas. We have now this smaller eastern little zone, and it has its own little islet that's floating in there, right? That seemed to scoot in around this whole train wreck of islets that gathered over here. And then we have this larger area that's still on the other side of the septum over here to the left of our image, to the west here. So, which once again indicates that we have 2 circulation sources within this area. One is lava coming out through here somewhere and circulating back underground in that zone, and another one is obviously coming out more or less in here and circulating back in under the lake here somewhere. And I would suspect also feeding the central pit over in this direction over here. Now, that relationship of the central pit and this eastern lake is fascinating, because when we saw these gas bursts come up, they're coming up out of the central pit and out of the eastern lake, right? So the gas somehow, when it's coming up and out in these big slugs, finds it easier to come up through that central vent. And the lava, otherwise, its pathway that is formed, its conduit, it seems to be wanting to feed at least somewhat to that southern fountain within the eastern lake. Then maybe it's feeding there and the northeast area and the central pit and other areas we can't see as well, but that's what we have the evidence for at this point in time. There's a little changing landscape that's down on a crusted crater floor there. So we can turn to the B1 camera here, also for the last couple weeks, and I'm going to zoom this in. We're not going to look at the overflows from this, the ooze-up flows from this area, so focusing more on the islets over here, and this is that closer side. This is that separated area on the east. So you can see these islets drifting around and coming in to separate the lake into 2 once the lava level drops. This is not the best view, but for completeness, I threw it in here. And interesting to note, I was trying to see from this angle, it's hard to tell, but this islet seems to actually get taller and rise over time. It seems like maybe because it's a combination of 2 or 3 different blocks, maybe they're pushing and moving together and somehow wedging up in the joints. Because it does appear that over time, as you look here, that feature does appear taller. So not the best view. Let's turn to the better one here, and that's our V1 camera. So here it is, the full sequence from 2 weeks ago. I wanted to point this out because You actually can see two fountains here 2 weeks ago, right? There is our closest to the fountain islet. You see the fountains change quite a bit. It changes from 2 to 1. Sometimes it's a little lower, sometimes a little higher. It actually disappeared for a little while during that lava drop last week. See the camera jumps there, but we're back to our single persistent lake. It actually moves to 2 fountains here on the 3rd. A little less than a week ago. Back to a single one. That one seems to move around. Here comes the second one once again on the 5th. And then it goes back down once again to a single fountain. And now the lava levels are seen to be the same level as these islets. They're all rafting in from the edges of the pond. And then coming to this morning, this is when we see that sequence I showed you at the beginning of the lava levels actually dropping. And so, let me pull that one back up again here. From earlier, that faster sequence just showing the last 24 hours and the lava fountain reducing in size there. And it's still sputtering, but it's obviously quite a lot less volume and height than it was yesterday. And you can still see movement of the lava within the pit. But if I pull it back here once again to the live view, what's something to do? Live view here. Then you can see that there's only certain areas that are showing these outbreaks of red, and other areas are looking much more crusted over within here, for example. So that was the story of all the webcams for the week. There's a few other little things to point out. Thanks to 2 Pineapples, we have this little clip of a little overflow down in this corner right over here. Let's see if I can put that a little more on the screen there. And there's our fountain, and you can see there's that levee wall getting breached and small flow coming out and spilling out of that central lake area. Then eventually the crust will come and clog it back up again, and this thing ends up building topography that makes the wall slightly higher here, and it essentially heals itself over time there. So thanks for clipping that, you guys. You guys are doing a great job streaming all that USGS content and picking out the cool stuff, as well as going out and filming your own highlights of Kilauea. So we'll feature 2 Pineapples once again here on our lava viewing report. And this is a small compilation of some of the views that they shot on the 6th 3 days ago here. This appears to be from the Wikahuna overlook. So some wide views, you see that larger crust, and you can see how many red cracks are within it, right? So that whole thing is moving, just too slow for the eyes. And then lava fountains, if you zoom way in, you can see that dome fountain a lot of the times bubbling, and you see behind it another place where the crust broke open. You have more transient fountains occurring like that, where gas is escaping from beneath that hardened crust. And in the upper right, you see that zoomed in view, right? So let me see if I can focus on that a little more here for you guys. And there's that zoomed out view there. From Kīlauea, that fountain on the east. Here's our little septum right through there, and separating our smaller pond in the northeast of that eastern lake from the other stuff here in the west. And still very red a few days ago as this is occurring, but I would imagine tonight we'll have a little bit reduction, and then likely tomorrow, maybe the next day, depending on how the cycle of deflation and inflation comes, we'll see the lava rush back in and burst back out, and it'll probably reoccupy all those areas and do some interesting stuff there. So we'll see what Kilauea has in store for us in the next couple of days here for next week. So mahalo once again to 2 Pineapples for sharing this footage with us here from their live stream. And check them out on YouTube for continuous streams. And I'm just showing you the very, very brief teaser, right, the trailer for the full show that's going on there every week. Right, so that's from 2 Pineapples. We have a couple other images that Dane highlighted here. One's from Stephen Davies yesterday. Fire Lake here. Posted on Hawaii Tracker, Facebook. And nice view. This looks like it's possibly also from Wikahuna. You see that fountain over on the right side and that cliff wall and a background behind it there. So a really amazing image there. Mahalo for sharing. I'm showing that, Stephen Davies. And one more from Maria Miller-Nickel, posted yesterday on Hawaii Tracker. And despite the rain that's occurred in recent days, she was able to get out, I think on Tuesday there, and get some really nice landscape views of the area there. So this is the view closer, it looks to me like it's closer to Volcano House, something like that, right? So don't see as much of that full lake extent, but you really see that dramatic illumination of the crater walls behind there and a little bit of the lava here, right over the rim in the foreground too. So that's the couple examples of viewing. Viewing's still good. Yeah, what you got, Dane?
Yeah, I mean, it's just, these are really good photos to, you know, just for these guys to take the exposure on these things. I mean, it's the hardest part with the lava. It seems like, at least when I play with it, the exposure is always wrong. And these guys are able to not only see the lava without it getting blown out, but pick up, you know, features in the background. So it's, you know, pretty impressive, their art form that they do.
Yeah, really, really challenging, right? You try to capture something that's extremely bright against something that's extremely dark. Very difficult. Yeah.
Very difficult.
Sure. So yeah, great images. We'll, to complete our viewing here, just mention that if you're planning to go and view, you can check the National Park website. They have all the updates on here, links to the live streams, images of the parking areas, and typical views from those areas, right? And of course, everything's weather dependent. Today it might be off and on depending where, but I always tell people you can never tell when you're up there when, you know, what the topography is going to do to the weather. I've been coming up from Hilo and been raining the entire time and got all the way up to Ukahuna and looked down into the pit in the rain and could see the lava lake still. It clear as day. So it really depends on how bad you want to see it and what you're willing to try. Get a good view there. So there's a viewing in the national park. And here is the map, and it's just to highlight, Ukahuna is the area that's all the way in the end of Crater Rim Drive west here. And the other one we often mention is Kankakoi in the south. These are the two ones that are slightly on a drier side. Right? You actually can see a little bit here of the vegetation on the volcano. I mean, there's a little bit of influence of where lava actually flowed and all of that. But generally speaking, this is the wet side of the volcano over here. Right, so Kupina'ipali is a fantastic place to view as well, but when we're having weather like this, where it's a little bit more moist or foggy, that usually is more obstructed in my experience there. So check it out if you can. If you can, I recommend going all the different places, but if you got to pick and choose, then those are some points that might help you make some decisions there. So there is the map, and we'll switch just to air quality as well, because in the park, one good thing about all this rain is it clears out all the fog. Unfortunately, it can also interrupt some of the station's telemetry and reporting, so some of the stuff is not actually updating online. But what is updating online is all green here in the national park. Right? See, there's a few gaps in there if I put it on the map. Summary up here. No, it's not going to respond, but you'd see that some of these dots are showing gray instead of green there. Right, so that's our air quality and lava viewing kind of overlap right there. So we'll move on to our VOG forecast, and VOG levels are similar to before and as far as being emitted to the volcano. However, the impact on the island is a lot less now this week because it seems like these strong winds. We've had wind warnings, high wind warnings here on Hawaii Island in the last couple of days. And also the rain can, like I said before, help clean out the air. So, however, we still have this input average value of 2780 tons per day coming out of Kilauea and drifting to the southwest for the most areas in South Kona and South Hawaii, Pahala, Nalehu, Ocean View that may have these impacts as well. Cut out?
Yeah, we've been having some lag issues, but that one was pretty significant. It had like a couple of them back to back there, but it's just continue on, I think, and we'll just we're almost there.
All right, so yeah, just a real quick recap. Same amount of gas coming out, but extra wind, extra rain help clearing it out, and still having impacts here in Pahala, South Hawaii, South Kona as well. So we can see that by going to purple air, which is looking a lot better than it did last week. We're not seeing all the yellows and reds, oranges that we were seeing last week. If it loads, it seems like I'm having some issues here. But mostly in the greens and a little less, there it is, a little bit more in a yellowish in the greens here on the Kona side. So still a little bit of impact, but not as much as before. I'm going to close that one because it seems like maybe closing some of this stuff might help me here. So, second, see if I can improve any of this performance here for you guys. All right, keep it moving here. So, all right, let's move to monitoring. On Kilauea monitoring for the last week, here is our lava depth at the top. Lava levels have gone up for the most part. There's this little variation occurs right in here on a 5th, right? One thing that I pointed out last week is that it does appear that this laser rangefinder is pointed at that western pit from the previous eruption, so it's not showing the full variations in the eastern lava lake. It is showing you something about the input of lava into the subcrust area within the crater there. And so if that's coming up essentially, apart from one small variation here, it's coming up all week, then it's telling you that the input of lava is likely still pretty steady as well. Down here on a tilt, we don't see any distinct event during that same time period, right? Which leads us to believe that it's something more on a surface, some small surface effect. And really the range of this is from 387.9 to 387.5, we'll call it, meters on this scale. So you're talking about 2 feet or so of variation up and down here across that western lake surface there. So it's a big area, so it does add up in volume, but in the grand scheme of things, we've seen bigger variations than this in the past, right? So likely something local there. Did not see that expressed underground. Really, the tilt spin is pretty flat, and maybe you could maybe call it slightly rising, very, very barely. Not significantly. And then we have here today our big deflation inflation event that begins and bottoms out, right? So this is the last week, and if you're just looking at the last week, and we've seen some questions come in about what's happening so different over here. And one important thing, as always, is to look at the scale on the side. So our scale on this plot here is going from 1 microradian to a -1 down here. So we're looking at 2 microradians total across this whole graph, right? And so we're going from slightly above 0 to slightly above, we'll call it 1.5, right? So you're dropping down about 1.5 microradians or something like that, right? Which is not a huge number compared to what we've seen in the past. So it's easier to see that when we look at the month-long plots. And so let me scroll down to that month-long. There it is, tilt right there. And so there's our most recent event. Our last week cuts off the last DI, so we're looking at the last week as just being in this. But here's a deflation inflation event that caused a lava drop last week. And here's the one that we're currently in right now, this week. I'm going to zoom it in for you guys. Maybe. Yep. There's the last week's one. And there's this week's one. So this week's one is expected to do the same thing. It's expected to actually turn around, come back up, and then flatten out again and continue whatever pattern goes from there, right? So that's an interesting thing. And the interesting thing really is that if you look at this last week and a half, right, the tilt has no longer been dropping, right? It's really, as I mentioned, it's kind of flattish, maybe even slightly rising. And that contrasts to really up until February 1st, the whole end of January, our tilt was an overall decline, right, before now turning around. So some change is occurring right here where we're transitioning some in our phases, right? We're transitioning from not having quite as frequent deflation inflation events, that we're not having as much of a surface effect, right? We were seeing fluctuations and surges and overflows during these. So there was effect for sure. We talked about how the conduit must be fairly well established and open on there. But we've also now seen it stop deflating, go to steady or possibly inflating, and start affecting the surface in more dramatic ways here. So the lava level, once again in a western pit, not showing us fluctuations. Here it is for the whole last month. So it's not showing the very beginning of the plot. I suspect that this might have been one of these islets that drifted by the laser, so it's kind of ignore that piece of it here. But you can see that the lava level has been rising, was rising faster last month on average, and then really it's been still rising, but at a slower rate, continuously still. That hasn't changed. It hasn't leveled off at any point here. looking at a month scale still, here is earthquakes, and they've been pretty steady the whole last month. There's really nothing unusual to highlight there to bring out. And here's our SO2 emissions, the most recent measurement at around 2,800 tons per day right there. The previous one was 24, the previous one was 26, and then 3,000 right there, right? 3,400 is also on here. So all within a similar range, which is a fairly small 3,400 to 2,400 there, 1,000 tons per day range, which if I scroll it down here to the whole last year, right, we're looking at just this little piece right in here. So this one eruption that we're in now, back earlier in the month, was over 12,000 tons. We're down to 3,000, so that was a pretty quick spike and drop, and now we're kind of, it seems like likely still declining on average, but at a slow rate and pretty steady in the 3,000s here. Similar to much of the last year, as you can see here from the plot of that tail end of the last eruption on Kilauea, right there. And so I want to talk about tilts a little more, but let's just wrap it together with the GPS here. So here is the last year summit GPS, the lava, the magma coming into Kilauea, causing a north and south rims to spread further apart, causing the distance to increase and see this upward slope. The eruption occurs right in there, and then really it's been decreasing much of the time since then. See, there's a drop coming down all the way here, but really in this last week or so, it seems to also be holding steady, if not possibly slightly up. You can't tell at this resolution here. So it seems like the tilt and the GPS are in sync here at the summit. And to complete our usual pattern here, here's the East Rift, and East Rift is once again showing downward trends, contracting, the sides getting closer together, not filling with magma near the surface, and no cause for any increased concern at present here. Someday, but that's not what we're seeing anytime soon here. So yeah, so just going to come back to the tilt one last point here, right? I was talking about the scale of the tilt, how this is only 1.5 microradians, and so you come down to here, and then really in a grand scheme of things, you can see that 1.5 microradians right there. That's that distance, and you see it's similar to the distance that we've dropped down. Right, there's a distance we've dropped down from our tilt in the last month, from up to 2 down to this -1. So that's the more important trend there. The one that goes more like this. And then we have these little, it's almost like having hiccups in a way, right? Like it's got the hiccups, and sometimes they're coming in more frequently, sometimes it's coming in a little less. And we know that after it goes down, it's gonna come back up too, right? That's just the pattern that we've seen for years and years and years. And still trying to untangle it. It's not quite clear exactly, because it's hard to track that dense magma going down, the gas coming out, all that stuff, but it all seems to fit together. Okay, so that's the monitoring graphs for this week. I wanted to, as usual, credit our source and highlight where a lot of this information is coming from. That's the USGS Hawaiian Volcano Observatory. Mahalo, you guys, for all the great work and info you're putting out. I thought I would highlight a few of the update sentences from this past week. As you guys know, they're pulling out daily updates on Kilauea and weekly updates on Mauna Loa. And a lot of them are have a lot of repeated information, repeated text. So I'll just try to highlight a little bit of differences here. And starting with just where we were a week ago, on February 2nd, our last update, that's when we had that activity in the eastern lake begin to crest over and form an isthmus to smaller patches north and south, right? So that was just to give us a launching point. That was that last week, Thursday. By Sunday, they note that the eastern lake remains stable. Activity within the lake is 25 acres in size. The small southern lava fountain within the eastern lake is active and remains at normal heights of 2 meters, 6 feet, with bursts doubling that height at around 4 a.m. Hawaiian time. A second smaller fountain was present in the same area of the lake between 3 a.m. and 7 a.m. Hawaiian time. A smaller western lake in a basin, as well as the 2 smaller ponds in the central and south portions, remain active and unchanged with no overflows in the past day. A large breakout occurred overnight from 9 p.m. to 9 a.m. on the northern part of the crater floor, equal to or slightly larger in size than the eastern lava lake. They mentioned the live stream, SO2, hazards, all that as usual. And just one other thing to note here, they're now reporting this eruption of lava in 4 locations of Halemaʻumaʻu crater floor continued over the past 24 hours. That's the 4 that I highlighted earlier in our update, plus the 2, or in this case, the 1 breakout occurring noted here as well on Sunday. And then going to Monday, they note that The large breakout in the northern part of the crater floor continues over the past 24 hours, and a small breakout occurred briefly south of the eastern lake around midnight Hawaiian time. Everything else is similar there. So we'll move on to the Wednesday update. And Wednesday, they now note eruption of lava in 3 locations of Halemaʻumaʻu crater floor continued over the past 24 hours. Eastern Lake Sable, Southern Fountain, same, Western the same. The thing that's different, the southern small lava ponds activity is diminished. And that was the case yesterday, but by today it's returned. So I've been calling that intermittent there. And if we look at today's update, just to bring us current, we're still noting lava in 3 locations in the Halemaʻumaʻu crater floor this morning, but this may be updated. We'll see how they choose to handle that. But I'll show you. You can show you guys from the thermal camera that that south pit is flashing once again here after having gone quiet a little bit. So tip meter is flat. 2,800 tons per day of SO2, and nothing else has changed. No unusual activity in either rift zones, and negligible emissions of gas from pool. So everything all good still on a east rift zone front there. So I don't think I pointed out that small pit, so let me play it once again, and maybe I'll start it just halfway into the week here. So there's our pit right there. You can see it's still flashing, overturning with lava occasionally. And then it seems to go quiet for a day there. And getting kind of dark. Flashes in a couple times, seems to go quiet again. And then just today, after a little bit more quiet, seems to reemerge and be reinvigorated right around there. Start seeing some more convincing activity within that pit there. So, and of course, now the fume is coming in and obscuring everything. So that's that southern pit. And I thought I'd back up here and just talk about the overall pattern, right? This eruption, it's got all these interesting little changes, but really the pattern is not surprising to us. We've seen this exact same pattern eruption happen in 2021. The timescale might have been slightly different because slightly different starting conditions, right? 2021 started after a 5-month pause or 4-month pause, and this year's started after, we'll call it a 1-month pause or so, right? So maybe 2 if you're being generous, something like that, right? So slightly different timeline, but overall we saw lava come up, flood the whole crater floor, retreat to a smaller area, and now we're starting to see the pulsing of the lake, and then actually the whole hardening and cooling of it intermittently as well. So I thought I'd play you guys. This is just the beginning of the eruption of 2021. Right? So this is pre-2021, September 2021. And here comes the lava, floods the whole crater floor, retreats to a small area here in the south. You start seeing ooze-up flows occurring along the margins, and then you start to see it actually go through this pulsing where it goes all the way quiet and restarts. Right? So this actually led to full pauses on Kilauea several times at the beginning of that eruption. I think the first quasi-pause began in early December, so about 2 months into that eruption. We're about 1 month into ours today, so maybe it's a slightly accelerated pace there. But you see that as I let this video continue playing here, after that initial pulsing phase where it actually went quiet many times, it came back and steadily continued erupting for another, what was it there, like 9 months or so, right? With a more steady, boring lake, as Dane described it earlier, that was only fluctuating up and down a couple feet and not changing a whole lot afterwards, right? So it kind of had that. Last eruption had similar phases as well. It had that first phase of flooding everything, the second phase of actually pulsing and changing from a deflationary trend to an inflationary trend. And then when that happened, it actually became more consistent and persistent. It just took a while to kind of shift gears, so to speak, as it was going through that. So here we are today in 2023, seeing a similar kind of pattern, seeing a similar change and a change from deflation to inflation on a tilt long term. Not talking about the small cycles, but the long term trend that we also see on GPS, and a well-connected pathway up, so the gas can burst right out of there. So it doesn't seem to me like any prognosis has changed. We're seeing a similar pattern as we saw in 2021, and we'll see if we actually come to a full pause here at any point in this eruption, and if that's part of the growing pains, so to speak, before lava bursts out from other areas of the crater floor. But it does seem pretty convincing lava still coming into the volcano. It's still coming up under the crust and still filling the areas. It's got to come out somewhere. Just when and where and how often and what pattern and all of that. So I thought that would help us put things in perspective. Since things are currently changing as I'm talking, I thought I'd keep checking in on the live cams. There's our live image from the KW camera and the rainbow coming in there in between the rain clouds. And it looks like there's breakout coming in from that central pit once again. Right, and very well-defined islets here in the background protruding above the surface of the lava lake. And that's the KW. Let me scroll down. F1. So you can see in the F1, it looks like some reduced activity on the eastern crust itself. Now, I do have a caveat that when you have extra fog and fuming away, sometimes it does kind of dampen these colors a little bit and make them not quite as bright. So there could be some of that happening. But it does also appear that you have more crusting occurring on that lake at present here, and that may be something that will last still until the deflation resumes and however long it takes, a few hours or a day or more perhaps. And even during this deflation, we're seeing extra continuing effusion from the central pit, right? So it's interesting to note. This was a place lava burst out of at the very beginning of this eruption. When we talked about that lava tsunami that came and flooded across the crater floor, it came out from here, right? So it seems like the gas, when it's bursting out, it's coming easily up from the bottom, most often through here. So this one seems like a suspicious area here. And one thing that's happened over the last week or so is as this overflow has occurred, first little ones in this area, then coming out further, and now going out to these larger areas, it's actually building up a hill around itself, right? It's actually a lava shield. A small version of that. That's what we call this form of hill that's got these shallow slopes, but still what's happening is you have this hill and on the pits on top, and when it overflows, it's sending flows down the bottom, and that hill just gets adding more and more layers. Right? And so that's why you're starting to see, rather than just a ponded area, you're starting to see actual lava flows running downhill away from this pit on the hill out into other parts of the crater floor. So that's interesting to note as well, how you're actually going to start forming a hill with a pit on top over here, right next to this larger perched lava lake area. So really cool how many different features you can form with one eruption. And we're starting to approach this whole complexity and intricacy that Jagger described back 100 years ago when he was coming and talking about 6 or 8 different pits of lava, all circulating independently with different things happening in each, islets bobbing and rising and moving around. And so we're just about there, it seems to me, with this diversity of activity all across the crater floor here. Okay, looking in at the V1, there it is. You still see some red and keep catching different views of this. Move on from that one. There is a S1, lots of exposed blocks still visible. You can see only a few spots of red. It'd be more telling at night. And I think that's it. Here's our B1 camera that's got a giant steam cloud here in front of it. Not seeing much of anything in there. So, maybe one last peek in at the live view here. And this is from an hour and a half ago, so let's give it a current. There it is, and so maybe just to emphasize, the islet's moved in a way here, but you can still see it's clearly still shooting out. It's not shooting out quite as much as before. A little bit higher. We had some questions transmitted early before update today. Mahalo to Pineapples for sharing this with us here, wondering about the dimensions of some of these blocks, right? And it's really hard to tell. We don't have exact numbers here. But we have reports that this lava fountain in the past that was more or less like this size, like that, was about 2 meters or so, right? And with bursts up to 4 meters or so. And so we're talking about 6 feet, bursting up to, call it 15 feet or so. So in comparison, it seems like the block that's right behind it right now, right, it might be in that range of, call it 10, 15, 20 feet-ish, as far as how high it actually is there, right? And if that's the case, then you're looking at being, well, it might be like 100 feet long or something like that, right? If that's 20 feet going that way, then you might have 5 of those, or 80 feet going the other direction over there. So that's one of the bigger ones. You can see a smaller one over here. And it's interesting to note that some of these, when you see them at the surface, they look a little bit smaller. And at the bottom, they're quite a lot larger than that. So depending where you actually measure it, you can come up with some different numbers. And interesting to note that like this was all beneath the lava level, right? So that's how much lava is drained out within this event in the last 24 hours here. This is a spot in the back I keep looking at as well. There's that crack. You can see this big chunk just fell in the last 24 hours too, and that's when the lava comes back up. You can imagine it's going to come up and go back through here and make another islet. So pretty soon we're going to have more and more islets every time the lava level drops, and you see more of these chunks fall into the lake and getting pretty clogged in there. And that does, combined with the less lava coming out of there, does lead to less circulation, the crust stagnating, and this whole pattern we're seeing here. Okay, so let me move on to the earthquakes. So on Kilauea, not a whole lot. We kind of cover this, so we'll go quick here. Not a whole lot in Kilauea on the summit. You see a little bit of background on the summit still, background on the south flank, and what's the new normal of Pahala still ongoing, maybe even a little less than normal down there. But some of those events were a little bigger, so overall, similar release of energy. And here's a whole last month, looking pretty similar to our usual patterns. So we'll turn to the USGS earthquake page. Here it is. This is showing earthquakes for the last week. And there is a Pahala zone, Kilauea, not much to report. Mauna Loa, not much to report. You're still having a few of these scattered post-eruption events, but that's kind of normal background for Mauna Loa as well. And it's actually kind of a little less than usual. So really not much to talk about on any of the volcanoes as far as earthquakes. The biggest events this past week, 3.3, 3.2, 3.2, 3.1, 3.1, all in a deep Pahala zone, 25 miles down, 36 kilometers down or so. So it's all part of that pathway from the hotspot that's getting mapped out and studied more and more, that we'll hear more about over the coming years. So those are the earthquakes. As usual, we'll touch base on Mauna Loa briefly here. As I teased here at the beginning, not a whole lot new in Mauna Loa, but we'll still show the graphs. Here is tilt for the last week, going up slightly. Note to scale 0.5 to minus 0.5, so we're actually only gaining half microradian a whole last week. Mauna Loa is a little more subdued usually from these summit tilt changes, but there it is, still only a slight change. And here's the month-long view showing that still increasing, slight change. That corresponds with the GPS, just like Kilauea. They're matching. Here's GPS at Mauna Loa summit, north to south, once again, still spreading apart, right? Which is normal as magma comes back in to replenish that erupted volume that the volcano just expended in this last eruption. So that's normal. It refills itself, and it'll refill to equilibrium, and then usually rests again and kind of keep building over the years to the next eruption after that. So that's the north to south distance in Mauna Loa. Here is the up and down. At one of those stations, you can see it's actually still coming up. So not only is the sides of the crater moving apart, they're also rising slightly. And that's how you know magma's coming in below and actually filling that area. It's a volcano. That's what it does. It fills with magma continually. And as we've talked about for much of the last, 5 to 10 years now, it's a lot of the magma actually just in places in the volcano and freezes inside. That's how it actually grows. And once in a while, it actually has enough to come all the way to the surface and make a surface flow as well. So that's part of its normal growth, filling with magma. It doesn't always erupt, and may lead to an eruption. Will lead to an eruption again someday, but doesn't necessarily lead to it just from that one signal there. Earthquakes are really quiet at Mauna Loa summit. There is the last week, and the last month, pretty sparse as well. More background events showing up here. So that is it for Mauna Loa. I showed Mauna Loa update before, and just to reemphasize, this is our source USGS, not erupting, and really everything else is the same as before. They're expecting additional shallow seismicity and other signs of an arrest to precede any future eruption, if one were to occur, right? Kind of in a short term. That's how I'll read that there. So there's one last thing on Mauna Loa, and that's the volcano watch this week. And this was shared on HawaiiTracker.com. Check that out if you want to read the whole article. On the road again, chasing Mauna Loa's gas plume. So there's a lot of detail and background information in here about what gases are emitted, the challenges of measuring SO2, whether you have trade winds and a coherent plume where you can then drive your car and look up at the UV source, usually the sun. Sometimes it's the actual lava fountain itself, if you can see it directly from like through the plume, but quite often the sun. So they drive around and shoot the instrumentation up through the cloud towards the sun, and have to drive it underneath wherever the plume is going. So if it's on Kilauea, they usually drive on a chain of crater, or the Crater Rim Drive road. Although we did see video of them going out across a desert, since the road is not all the way there anymore to get that transect. Mauna Loa is a lot bigger, erupted a lot higher, dispersed a lot more, so they had to drive a lot more to get all that data. And as a note, they could only do that in the daytime, right? So they came up with some interesting measurements, and I'll skip down here to the bottom. They ranged from 200,000 to 500,000 tons per day of SO2 early in eruption, and we're just over 100,000 tons per day later in eruption. By December 8th, they dropped it down to 30,000 tons per day, and at the end of the eruption, December 10th and 12th, only 2,000 tons per day, and then not even detectable at the end there. So that's very similar to 2018 Kilauea, which was nearly 200,000 tons per day for part of the eruption. So similar ballpark there. And in total, they think Mauna Loa erupted over 2 million tons of SO2 during its most recent eruption there. This doesn't include a large volume of SO2 that satellite images show was emitted with the initial fissure opening overnight between the 27th and 28th of November. We need UV light to make these driving measurements, which means they can only be conducted during daylight hours, and so they could not drive around that first night overnight when that first burst came out. So that is some of the details there. In 84, they reported roughly 100 to 200,000 tons per day from satellite as well, with less sophisticated technology. So it's probably pretty similar to what we're seeing here in the most recent eruption of Mauna Loa in 2022. So that's it. They're down to about 0 at Fissure 3, and no more measurement of gas from Mauna Loa there. So it kind of wraps up the Mauna Loa gas. There's always refinement coming in, and they can probably add that satellite, integrate a satellite with the ground measurements at some point, and come up with an overall volume and report that to us, I'm sure, as well. So that is our update for this week. We do have our community events to highlight once again. As usual, we'll talk about the national park. You didn't check out Two Pineapples stream After Dark in the Park this past week on the bird conservation program in Mauna Loa. That is kind of related to what we're just talking about there. It's interesting. Check that out. You'll be trying to bring those to you guys regularly as possible, right? And along those lines, After Dark in the Park continues next week with virtual visit to Papahanaumokuakea National Marine Monument. So that's on Tuesday at 7 p.m. And once again, Valentine's Day, the day afterwards, Wednesday, special added program, Ben Ka'ili in concert at the visitor center up there. There are also events occurring outside of the After Dark in the Park. There's kahuku events, so this is stuff in the past. The carving was yesterday. But kahuku on Anki Land Pools, Saturday the 18th, 9:30 a.m. at Kahuku. In addition to the usual kahuku events that are occurring and the usual Dr. Jagger interpretive performance by Dick Hirschberger. So you guys should check it out. Check out our coverage of that in the past and go see what that's like if you're curious. Fantastic program. There's also the added program announced for Ben Miller that is occurring Saturday, February 25th, 11 a.m. to noon at Kahuku as well. Comedian, which would be an interesting presentation there. Unfortunately, we won't be able to make that one day, and we have other commitments that day, but maybe we'll be able to watch a video of that at some point if we're lucky. And the park just came out with their March events as well, so they're about a month in advance here, but since it's came out already this week, I thought I'd go ahead and preview some of this. They are having Healing with Plants and Spirituality at Ohia Wing on March 8th. They have Taiko Drummers, Puna Taiko Drum Group, coming in Tuesday, March 14th, 7 p.m. That'll be a loud and exciting performance. These guys are awesome. We saw them at some of our resilience hubs outreach, I think at UH and then Kahuku, there's a talk about Kīlauea and Kamehameha, cousins bitter rivals, March 18th there. And so those are the highlights for March. And that is it. At least there's one last news item that I seem to have missed here, and that is just on Mauna Loa, a little bit follow up here. News from NOAA that Mauna Loa Observatory is going to get upgrades, get a battery storage system to bring that facility back online to be self-sufficient in power. But in the meantime, I've been collecting data in collaboration with Paradise Helicopters by sampling, having an automatic sampler. They're dropping off a sampling kit and picking them up after a week. And they're continuing to make sure that data stream is uninterrupted there. So this is also posted in Hawaii Tracker, so check that out if you're interested in that. And all that said, Dane, I think we're ready for some thank yous and questions.
All right. Well, want to thank everybody that tuned down in today. We rely on viewers like you to get this information out there. Really, the likes, the likes, the shares, and all that stuff really drives the algorithm and gets the people to see this put on their screens more often, and that really does help the channel. So likes, shares, subscribes, all that. We had a couple people come through with super chats. Want to acknowledge them real quick, including a $50 or $49.99 super chat from Catherine. I need to move this.
Wow,
and it wasn't a comment on that one. And then we had Chris Kiki come through with a $20 super chat and said thank you, Phil and Dane. And Mark dropped a $10, no comment on that one. And Yan Zhao came through with a $4.99 and says, enjoy your videos. Found you by a chance. I appreciate you sticking around.
Mahalo.
All right. Thanks, everybody. And we'd also like to send a thanks to the County of Hawaii, who helps bring this type of content to you. They've done so with the Vivite Grant program and funding this type of content, as well as our written content, short videos, and things along those lines that we post on Hawaii Tracker and here on Hawaii Pod. If you're not a member of Hawaii Tracker, that is where most of the interactions with the group happens. The group's now nearing 115,000 people. Ton of very talented photographers, videographers. They all do their own little projects and put it out there. So it's really good collaboration going on over there. We also post on hawaiitracker.com. That is our dedicated backup website that we control in case we ever get banned from Facebook or YouTube or anything like that, because hey, you never know with those guys. I believe that gets us through most of everything in that regard, and we can get into some questions. We don't really have that many, but we can get into some. And if anybody does have any questions, throw them in the chat and we'll try and get them in there, huh?
Yeah.
Right. So Michael asks, is Kilauea the only one on the island filling up with lava, or is Mauna Loa filling up as well, or Mauna Kea even?
So I just saw my screen just flash red, so just in case I cut out there, I'll repeat it. The question was, is Kilauea the only one on the island filling up with lava, or Mauna Kea filling up also? So Kilauea is filling with lava, Mauna Loa is filling with lava, Mauna Kea is not filling with lava. And the way we know this is there's a repeated earthquake signal that has been proposed to be a result of the actual gas kind of fizzling out from a cooling magma chamber. So there's magma still in there, and the gas is bubbling out from the magma a little bit, very, very slowly, much more slowly than something that's being fed actively. And it's separating, but it's actually causing this repeating earthquake they can detect up there in the saddle. Thousands of them happening over the last many years. So that's how we have a clue about Mauna Kea. You can probably be confident that volcano formerly known as Loihi, Kamaehua Kanaloa, is also filling with magma, but not Mauna Kea, not Hualalai, and not Kohala likely, right? Now, filling with magma is a little bit different on Hualalai because Hualalai is still active and has it will erupt again. But the recent eruptions of Hualalai seem to show that there is no near surface magma chamber there, right? It's something that comes from deeper down and comes up quite a bit faster, which is a bit concerning, because if you're having that hotter, deeper magma coming up faster from below, that can cause, and without as much monitoring signals, that can cause higher exposure, right, to risk there. So
it's also the unknown with walleye. The lack of there being an eruption in modern history is really adds a layer of obscurity to the thing, right? We kind of know about it, but we kind of don't. Like, whereas Mauna Loa, it's like, yeah, we've seen this song before, even though it hasn't sung in a little while. The records of it are there. Kilauea, it sings all the time. Walleye, the last song was just out of our hearing range, basically.
Yeah, and think about Mauna Loa. With as many times it's erupted and as much information as we have in a historical record, we still only had 2 modern-day eruptions with instrumentation, and we still weren't quite sure what all that instrumentation was telling us as it was coming up, right? And that's with one of the most active volcanoes that we have, and so imagine having 1/100th less data than that, and nothing to go on. That's walleye. So we had just back to the geology, and we know what can happen. But it's really hard to say anything with any confidence further than that, right?
Right. All right. Hey, we had some lag issues in the beginning of the stream. Apologies to everybody, and appreciate everybody that stuck around this far into the stream. And that kind of, I think, cut into your little intro segment. So I was seeing if you wanted to give it another shot at it. I think all you got to do is the beginning of your summary, and we'll be able to clip it together later in post. If you want to do that before we log off.
Let's see here. Let me pull that back up. And I'm not sure that my mind is an hour and a half from that point where I knew I was going to say in the beginning, unfortunately. Yeah. So, yeah, I'm not sure I can pull it off right now. Let's see.
Probably just like the first 3 sentences or 4 type of thing, and you're good.
Yeah, maybe I'll watch it later. I'll re-record those or something, because I can't come up with that from scratch right now.
All right, no problem. All right, well, appreciate everybody that tuned in today. And if you came out to some of the events that we've been taking part in on the weekends, the Resilience Hub, Makahiki festivals. We also had the Revitalize Puna, one of those. Mm-hmm. And yeah, a bunch of events, and we'll be trying to continue the outreach out there, get out into areas that may not know us. I mean, it's night and day when I'm in like Pahoa or Puna, on Kilauea, talking to people, and a lot of people know us and what we do. And then when I'm out in like Lani and Lapahoihoi, and they don't worry about the volcano. Yeah, they don't know about us that much type of thing. Yeah, so we're doing the outreach, trying to get out there more and more.
Yeah, for sure.
All right, well, that will do it for me.
Well, mahalo, Dane. Thanks for all your hard work this week, and leading the outreach on those events. I just have one last comment to throw out there. I am thinking about all those earthquake victims. Shout out to all those guys and struggling. The struggle was real with that for sure. I won't go into any more detail than that, but hope for the best. So, from HawaiiTracker.com, until next week, back on Thursday, usual time, usual place, 5 p.m. Hawaiian time. So until next week, from HawaiiTracker.com, he's Dane DuPont. I'm Philip Ong. Aloha, everyone.